This lesson is on solving quadratic word problems, so we're just going to go through some word problems and get some practice in solving for vertex and zeros while we have a word problem. So the biggest thing is just figuring out what they're asking you for. So the first step is always going to be to draw a picture. Jason jumped off a cliff into the ocean in Acapulco while vacationing with some friends. His height as a function of time can be modeled by the function negative 16t squared plus 16t plus 480, where t is the time in seconds and h is the height in feet. So we have Jason, and he is standing on a cliff, and he's going to jump off the cliff into the ocean. So when I look at his motion, it's going to create a parabola because he's going to jump up and down into the water. So the first question asks, how long did it take for Jason to reach his maximum height? Well, I know that his maximum height is this point right here. But that's the vertex. But I have to figure out what that means. So if I draw my x and y axes, I know that the time is on the x-axis and the height is on the y-axis. And what it asked me was how long it took to reach his maximum height. So they're asking me for the x value of the vertex. And I know that I can find that by doing negative b divided by 2a. So my b in this situation is 16. So that's going to be negative 16 divided by 2 times negative 16, or negative 16 over negative 32, which is positive 1/2. So it took him 0.5 seconds. The next question asks, what was the highest point that Jason reached? So this is asking for the y of the vertex. And since I already found the x, I'm just going to plug in that x value into the equation. So negative 16 times 0.5 squared plus 16 times 0.5 plus 480. Well, that's negative 16 times 0.25 plus 8 plus 480. So negative 4 plus 8 plus 480 is 484 feet. So his maximum height was 484 feet. The next question asks, Jason hit the water after how many seconds? Well, if I look at his motion, he's going up, maximum height, coming down. He's going to hit the ocean, and that's where it crosses the x-axis. So what I'm looking for is a 0. So what I'm going to have to do is factor and solve. So I have negative 16t squared plus 16t plus 480. I'm going to factor out a negative 16. And then I'm going to continue factoring that. And then I'm going to set those factors equal to 0 because I'm solving for this. So t minus 6 equals 0 and t plus 5 equals 0. So t can either equal 6 seconds or t can equal 5 seconds or negative 5 seconds. Well, I can't have negative time, so this doesn't make any sense. So the answer would be 6 seconds. The next problem we're going to look at is number 3. A rocket is launched from atop a 101-foot cliff with an initial velocity of 116 feet per second. Substitute the values into the vertical motion formula and let ht equal 0. So what that's asking me to do is to substitute the starting point for h sub 0, or s, depending on which form of the formula you're given, and 116 for the velocity. So what that's going to look like is negative 16 t squared plus 116 t plus 101. And then we're going to use the quadratic formula to find out how long it will take the rocket to hit the ground. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'll have negative 116 plus or minus the square root of 116 squared minus 4 times negative 16 times 101 all over 2 times negative 16. And what I'm going to do is I'm going to break this up into pieces. So when I break up the inside, I get negative 116 plus or minus the square root of 19,920 all divided by negative 32. And I'm going to remember that I have to do this twice because I have plus and minus. So when I add this one, I end up with negative 0.78. And when I subtract it, I end up with 8.03. Now when I look at these, it's asking me how long the rocket will take to hit the ground. So this one doesn't make any sense because I can't have negative time. So it's going to have to be here, but it asked me to round to the nearest tenth of a second, which would just be 8.0. The next problem we're going to look at is number 4. You and a friend are hiking in the mountains. You want to climb to a ledge that is 20 feet above you. The height of the grappling hook you throw is given by the function negative 16t squared minus 32t plus 5. What is the maximum height of the grappling hook? Can you throw it high enough to reach the ledge? So I am climbing a mountain with my friends. And I want to reach this ledge that's 20 feet above where I am. And I'm going to throw my grappling hook. And I want to know if the maximum height will reach that 20-foot requirement so that I can climb to that ledge. So I'm looking for the maximum height of the grappling hook. So what I'm looking for in a maximum is the vertex. And since I'm looking for height, that's going to be the y value of the vertex. So the first thing I have to do is find the x value of the vertex. And that's going to be negative b over 2a, which is 32 over negative 32, which is negative 1. I'm going to plug that in. Negative 16 times negative 1 squared minus 32 times negative 1 plus 5. So that's negative 16 times 1 plus 32 plus 5. And that's 16 plus 5, which is 21 feet. So the maximum is 21 feet. Well, it's only required to get to 20 feet. So since 21 is greater than 20, the answer would be yes, I will be able to throw it high enough to reach the ledge. The next problem we're going to look at is number 10. An amateur rocketry club is holding a competition. There is cloud cover at 1,000 feet. If a rocket is launched with a velocity of 315 feet per second, use the function negative 16t squared, that should be t squared, plus vt plus h sub 0 to determine how long the rocket is out of sight. So I have a rocket, and I am going to launch that rocket from the ground. However, there's some clouds at a certain point. That's cloud cover. So I might not be able to see the rocket the entire time once it's in the clouds. And I'm going to go ahead and draw my axis. Remember that this is x and this is y. So what I'm looking for is when my rocket will reach that 1,000 foot mark. So I'll have 1,000 equals negative 16t plus 315t plus 0. And the reason I'm adding 0 is because the rocket starts right here on the ground, so it starts at 0. And that should be t squared. And now I'm going to solve with 1,000. So I'm going to subtract that 1,000 from both sides. So I have negative 16t squared plus 315t minus 1,000. These don't have a greatest common factor, so I can't factor it that way. So what I'm going to do is I'm going to use the quadratic formula, which again is negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'll have negative 315 plus or minus the square root of 315 squared minus 4 times negative 16 times negative 1,000 all over 2 times negative 16. And I'm going to break this up by completing the inside of the radical first. So this becomes negative 315 plus or minus the square root of 35,225 all over negative 32. And when I add that, I get 3.98 seconds. And when I subtract it, I get 15.71 seconds. So at this point, it's at 3.98 seconds. And at this point, it's at 15.71 seconds. So what I'm looking for is the amount of time that is between these. So 15.71 minus 3.98 gives me 11.73 seconds. So that's the amount of time that the rocket will be existing in this cloud cover section and will not be visible. The next problem we're going to look at is number 12. During World War I, mortars were fired from trenches 3 feet down. The mortars had a velocity of 150 feet per second. Determine how long it will take for the mortar shell to strike its target. So a trench is like a little ditch in the ground. And we're launching that mortar from 3 feet under the ground. So that's negative 3. So my starting point is going to be negative 3. And then I'm going to launch that mortar upwards. Here are my axes. So my equation, the vertical motion equation, is negative 16t squared plus vt plus s, or h sub 0, which is just the starting point. So I'm going to have negative 16t squared plus 150t, because that's my velocity, minus 3, because my starting point was that 3 feet under the ground. And then I can use the quadratic formula to solve. And I know that when it's going to hit its target will be this point right here, which is going to be a 0 or a solution. So I'm going to use the quadratic formula. So negative 150 plus or minus the square root of 150 squared minus 4 times negative 16 times negative 3 all over 2 times negative 16. And again, I'm going to break this up by doing the inside first. So this becomes negative 150 plus or minus the square root of 22,308 over negative 32. And when I add, I get 0.02. And when I subtract, I get 9.35. The one that makes the most sense is going to be this 9.35 because 0.02 is going to be that first zero because it's further to the left. So it will take 9.35 seconds for that mortar to hit its target. I hope this has been helpful. Like I said in the beginning, the biggest thing is just figuring out whether it's asking you to solve for a 0 or the vertex and which coordinate of the vertex it's asking you to solve for.